So, sorry, this looks like a kindergartner has written it. My Apple Pencil is out of charge or battery, so I am left writing it this way. So, if we're doing, trying to take the derivative of this, I don't know if I would see it as a product with a very messy second term, or if I would want to distribute. I really think I would distribute first. So I'm going to multiply the x squared, and I would get 2x squared over the x minus x squared over the x. And then I'm stuck. I could either, I could simplify 2x squared over x to 2x, and then that's pretty nice. But then I still have a quotient here. I think that's what I'll do. My other thought was I could back up to this step and get a common denominator and add them together. And then I would just have I would have a quotient, but it wouldn't be too messy, I think. But it might be. So I'm going to go with this route that I have down here. So we've done simplifying, and in general, the more simplifying you can do beforehand, the better. So when we go to do our derivative of that first term, this is just a sum or difference now. So the derivative of 2x is 2 minus, and I'm going to start a parenthesis because now we have a quotient. So we're going to do low d high minus high d low all over low squared, and that is an x. All right, so that becomes 2 minus the top. I'm going to distribute, get 2x squared plus 2x minus x squared over that x plus 1 squared. Let's erase this. So that's going to be 2 minus x squared plus 2x, because you got a little like term there you could put together, squared. I don't really need those parentheses because it's all grouped now with the division bar. Probably the best thing to do is make that a fraction so you can butterfly. So it's 2 times x plus 1 squared minus, multiply that other way, x squared plus 2x, all over the x plus 1 squared. And then it's just the algebra just keeps on going on these. That's why they, unless you love algebra, that's why it's a lot. I'm going to FOIL this out above it and do x squared plus 2x plus 1. So I can distribute my 2 to all those. So that's 2x squared plus 4x plus 2. And then let's distribute this negative 1 to these. Minus x squared minus 2x all over our denominator. I am so sorry about the quality of my writing. And then we need to do the last step, I hope, would just be to combine like terms. So I would get an x squared and a 2x and a 2 over that x plus 1 squared. All right, there's 34. 38, f of x equals c squared minus x squared over c squared plus x squared, and they say c's a constant. So they could just have easily have said 3 squared or 5 squared or something, but c's just a constant. So every time we take the derivative of that constant, we're going to get a 0. So they're just letting c be a variable, but it's not really a variable, it's a constant. So when we go to take the derivative, this is a quotient, so we're going to do quotient rule on it. So we're going to do low d high minus high d low over low squared. So c squared plus x squared times, we go to do the derivative of the high, the derivative of c squared is a 0 because it's just a constant, and this is negative 2x, minus high, c squared minus x squared, times derivative of the low is the same thing. This is just 0, and that's a 2x. All over low squared. Okay, so let's do some distributing kind of this way. That's negative 2xc squared minus 2x to the third. And here, minus 2xc squared minus 2x to the third. And then when I distribute this negative 1 right here, let's see, then we're going to get negative 2xc squared and negative 2xc squared. So that's negative 4xc squared. And then we have negative 2x cubed and then plus 2x cubed. So that's gone. Over c squared plus x squared squared. So that's our answer. And then I had one example I wanted to do for you to wrap up 2.4. I wanted to do example 9. And it was y equals parenthesis 3x minus 1 over x squared plus 3 squared. So you could write that down twice and FOIL the top and FOIL the bottom. Be a lot of algebra. Might be worth it. You could also see this as a chain rule problem. Overall, it's a chain rule problem. But when you go to do the derivative of the inside part, it's a quotient. So it helps to think through the steps, I think. So I'm going to work it as a chain rule problem. So I'm bringing 2 down the front of all that inside stuff and making that power be 1 less. And then I'm doing the derivative of the inside part, which is a quotient. So x squared plus 3 times 3 minus 3x minus 1 times 2x, I can't get that to fit there, all over x squared plus 3 squared. So I just ran through low d high minus high d low all over low squared. Well, first off, this being to the first power would just be the same as if I hadn't written it there. So there's nothing stopping me from distributing this 2, seeing it as a fraction 2 over 1, and distributing the 2. So let's call that 6x minus 2 over x squared plus 3. And then this is multiplied. Let's see. Let's distribute the 3 here. Call that 3x squared plus 9. And then let's distribute the 2x here to both of these. So minus 6x squared plus 2x. So I took care of that minus also. All over x squared plus 3 squared. Okay. Now we're multiplying 2 fractions together. We should probably clean up the top a little bit. Let's leave that 6x squared minus 2. 6x minus 2. And then the other numerator is negative 3x squared, because we have like terms, plus 2x plus 9. But the denominators, those are like bases. So one of them and two more gives us x squared plus 3 to the third. We do need to distribute all the numerator. Be nice if my pencil worked. Okay. So that's negative 18x to the third plus 12x squared plus 54x plus 6x squared minus 4x minus 18 all over x squared plus 3 cubed. So that is negative 18x to the third plus 18x squared. This is a 4x here. So plus 50x minus 18 all over x squared plus 3 cubed. Oh, you won't believe this. They didn't make me do all that algebra. You never can tell what they're going to want you to do. They let us stop actually here at this line. Actually, they didn't even distribute the 3. They backed up one line before that. But they did get the bottom to x squared plus 3 cubed. Okay. So on a test, you could say, have I gone far enough? And I could tell you, no, you need to keep going, or yeah, that's far enough. So what you need to do as you're preparing for these sections is go back and rework some, especially some that gave you trouble the first time that we've worked out together in class. Take some time and go back and rework them. All right. I'll see you all next Friday.